Okay, today we're going to talk about percent composition. So this is the start of 11.4, and you'll want to take your own notes for this. The worksheet that I gave you in class, or the one that you can print off of Skyward, is the one that you'll want to do for homework kind of after we've gone through a few examples. You'll really want to practice and understand what it means to have the percent composition of a compound. So let's go ahead and start talking about that. Let's think about the word percent. The word percent, typically a formal definition is part of 100, or you have some fraction or some part of a certain total. And usually we think of that total as being 100. So composition you can think of as being what is something composed of. So if I have a certain compound, it's going to be composed of or made up of a certain number of elements, and each element brings a certain mass to the compound, depending on how many of each of those little elements I've got. So when we say percent composition, we're just trying to figure out what percent do I have of a certain element's mass within the mass of a compound. So here's how we figure that out. Here's the formal definition, percent of each element in a compound based on the mass. So we find the mass of that element that's present and we compare it to the mass of the compound. Or what we've done before is the molar mass. So here I have the formula we'll use to calculate percent composition. So you always want to figure out the total mass of your compound, and then you want to put that on the bottom, and then that's like your total mass of the whole compound. And then whatever element you're interested in, you want to take the total mass represented of that element, and you'll divide it by the total. And that'll give you a decimal. Now, that decimal should always be less than 1. If it's not, then you've made a mistake somewhere. Maybe either in calculating the total down here, more than likely, or you've got too big of a number up here, you didn't add something up right, or look at the right element on the periodic table. Anything along those lines. Excuse me. Then we'll take that fraction, whatever decimal you get, times 100, and that'll give us our percent. So that just tells us if I have this certain compound, here's the percentage that I have of this certain element. So let's go ahead and look at an example. Here it says determine the chemical composition of each element in sodium carbonate. So first of all, I have to know the chemical formula. It's not enough just to know sodium and carbonate, because when they actually combine, I might get more of one than the other. I won't just have one of each, depending on what the formula looks like. So here I have sodium. It's group 1, so it gets a +1 charge. Carbonate is group 3. Carbonate has 3 oxygens, so it's CO3, and it gets a -2 charge. That's one of your polyatomics. Hopefully you still have memorized. To get the final formula, we just crisscross these. So 1 will come down here. I have 1 carbonate, and I have 2 sodiums. So that gives me this formula, Na2CO3. Alright, let's go ahead and figure out the percent composition of each element that's represented. So first of all, I look at my elements. I know I have sodium, I know I have carbon, and I know that I have oxygen. Okay, so the first thing you'll want to do is write out what elements you've got. You'll look at your periodic table. You want to figure out the mass of each of those elements present. Alright, it's not letting me draw oxygen, so we'll work on that when we get there. Alright, so let's look at sodium. Sodium on the periodic table has a mass of 22.99 roughly. Okay, that's grams per mole of it. And I always assume that I have 1 mole of this stuff, so don't worry about the whole compound. Okay, I never have more than that. We're not worried about converting anything. I'm just worried about what percent do I have of each element. So now, in my compound, I have 2 sodiums though. So the total mass that sodium brings to the compound is 2 times this number. So the periodic table tells you what one of those weighs, and we have 2 of them. So we have 22.99 grams. Now, all you're going to do on your calculator is multiply 22.99 times 2, and that gives me, if I look at my calculator, 45.98 grams. So that's what sodium is contributing. That's how much mass sodium brings to the table, basically, when it comes with this compound. Now, to get the percent composition of this, let me make a little more room. What we have to do is take, this is the mass contributed by our element, so 45.98 divided by the mass of our compound, okay? And then we're going to multiply that by 100. So let's go and see what's the mass of our compound. Well, we're going to actually figure that out when we find out how much each individual element contributes. So let's kind of keep going here. We'll finish this out in a second. So here I'm going to have carbon next, and carbon, there's one of those, and each carbon weighs 12.1. 12.01. Okay, so total mass carbon contributes is 12.01. So when we go to find the percent composition of carbon in the compound, we'll put 12.01 on top. That's what it's contributing. We'll put the molar mass on the bottom times 100. All right, let's take a look at oxygen. There are 3 oxygens represented. Each oxygen weighs 15.99. And when I go to my calculator, if I take 15.999 times 3, get 47.997. Okay, and to do the percent composition, I have to divide by the molar mass. So let's take a look at what the molar mass is. So now I've figured out how much each element contributes. So the molar mass is just the total of those things. So I'll take each of these numbers I figured out and I'll add them together. So we will take 45.98 plus 12.01 plus 47.997. So my total molar mass, adding up each of these individual masses that I got, is 105.987. Okay, and then I'll multiply that by 100. Now, for sig figs, 100 is a constant. It's not something we're measuring. We have to multiply by 100 in order to get a percent. So that's a fixed number. So we'll look at these two numbers and figure out the sig fig. So here I have 4 significant digits. Here I have 6 significant digits. So my answer should only go to 4 sig figs. So let's take 45.98 divided by 105.987. And I will get this number times 100. And again, I only want to go to 4 sig figs. So here I have 43.38. That's as far as I want to go. The next digit is a 2, so that 8 will not get rounded up. It'll stay the same. So I have 43.38%. So when I'm given a mole of this stuff, or 1 unit of it essentially, and our unit again is the mole, this compound will be 43.38% sodium as far as the total number of grams of sodium. So let's look at the other stuff. So we'll take 105, not sure why it's not letting me write here, but we'll take 12.01 and we will divide that by our 105.987. So let me type that in, 12.01 divided by 105.987, multiplied by 100, and here's what I get. Again, up here there are 4 sig figs. 105.987 has 6, so I can only record 4. So my final answer for carbon's percentage is 11.33. Okay, and that's going to be my final answer as far as the percent composition for carbon. So here I have 11.33% carbon. Okay. All right, let's do oxygen, same deal. So down here we're going to take our total mass of oxygen and divide it by 105.987, always by the same molar mass of your compound. That's the total. Okay, multiply by 100. And here I happen to have 5 sig figs on top and 3 or 6 on the bottom. So I will actually take this out to 5 spots. So I have 1, 2, 3, 4, 5. The next digit is a 7, so the 5 gets rounded up to a 6. So I have 45.286% of my compound is oxygen. Now, there's going to be a little bit of a rounding error, but for the most part, you should have, these percentages should add up to 100 ideally, and again we've rounded a little bit, so it should be like 99.9999, or really, really close based on our rounding. But these are our percent compositions. Okay, so find the total mass contributed by that element, divide it by the total mass of the compound, and then multiply by 100 for the percent. So let's look at this in a slightly different way. We're going to calculate the same thing, but we're going to think about it slightly differently. So let's look at this problem. It says a compound contains 3 different elements. The percent compositions are given here, and the formula for the compound is LiOH, or lithium hydroxide. OH is hydroxide. It says identify the elements based on the percentages. So let's think about this. Let's look at lithium, and then I'll have oxygen and then hydrogen. How much? There's one of each in this case, so that's easy. So if I look at lithium, it's about 6.914 grams from the periodic table. That's how heavy 1 mole of it is. And then oxygen, its mass is 15.99. And then hydrogen is 1.008 roughly. So let's look at the total mass of the compound. So let's go ahead and add up these 3 numbers because there's one of each of these represented. So I have 6.914 plus 15.999 plus 1.008. So my total mass, or the molar mass of the compound, is 23.921. If I come up here, 23.921 grams. That's a total. Now these percentages are based on these masses of the elements that they contribute and divided by this total number. So just kind of looking at the 66.81%, well, oxygen's the heaviest thing here, so it should make up a lot of the mass of my compound. So the 66.81% is probably oxygen. That's element number 2 that they've got. Element number 1 then should be the next heaviest thing, or the next element that contributes the most mass, which in this case will be lithium. That's a little heavier than hydrogen, so it's going to make up a slightly larger percentage of the mass. And then hydrogen's the lightest, so it should make up element number 3, which is 4.21% roughly of that. Now, you can go back and check this, just get the percent composition of each element. So let's take 6.914 and divide it by 23.921. And when we multiply by 100, we should get really close to the number we've got here. And again, there will be a little bit of rounding error. So I have 28.9 and then again 28.98, fairly close. So that's the other way you can think of these. And we can do the same thing for oxygen, get its percent composition, calculate it, and it should match these numbers. So that's one way to think about it. The heavier you are, the more percentage you contribute. So go ahead and finish up the worksheet. You're just calculating percent mass. Sometimes I have you write the formula, other times the formula is given, but have that ready to go for tomorrow, and I will see you then.